All right, pre-calculus 35.2, number 6. In this question, it says to write an equation. Write an equation of a sine function in this form right here. So this is our form given all of the parameters for our transformations. A is a vertical stretch, B is our horizontal stretch, C is our phase shift, D is our vertical translation. And let's focus on A here. Amplitude is 4. So amplitude has to do with A, right? So A is 4. That's the displacement from sort of the middle of the graph to the maximum point or to the minimum point, if you remember science class. Or it's half of the total range of this sine, half of the range. So A is 4. The period is pi. Oh, okay. So period length, which is actually 2 pi over B, we know that the period is pi. So period length is pi. So that means I can solve for B here. So B is 2 pi divided by pi, which equals 2. So A is 4, B is 2 here. Okay. The phase shift is pi over 2 to the right. So for C, we have positive pi over 2, and that's going to show up as a minus pi over 2, right? You just got to kind of remember that. That's going to show up as a minus pi over 2 because it goes to the right. And vertical displacement of 6 units down, so D is negative 6. So if we put all these together, A, B, C, and D, then we can come up with our equation. And it's as simple as that. So y equals, I put the A in there now, 4. Sine of B is, we calculated to be 2. And make sure you have your brackets in there. X minus, so C is pi over 2. See, it shows up as a minus, just like we had stated before. And then minus 6 goes outside of this sine function. That's the vertical. Okay, so did anybody get that for 6a? Check your 6a. That's confirmed. Did you get that? Yeah? Okay. All right. Let's take a look at 15 as well. So 15 is a different kind of question, and this sort of would be from part 2. So these would be 2 good questions to focus on for this section. This one is, we're given a graph, and we're asked to determine the equation. I guess the other thing you'd need to do in this section would be, given an equation, draw the graph, right? So this is coming up with an equation as well, but we're not given a description of the characteristics. We're given just a graph. So we have to get these parameters from looking at the graph and doing our dissection, really, of this graph. So A, we know, is the amplitude, okay? Or it's half of the displacement from the maximum value to the minimum value. So what do we have here? We have a negative 3, looks like here, and we have a positive 1. So that's a total distance of 4 units. Half of 4 is 2. So A is going to be 2. Okay? And here would be the midline, or the middle of the graph. And we go 1, 2 units to get to the highest point, or we go 1, 2 units to get to the lowest point. That's what that means. Any questions about A? Okay. All right, what about B? Okay, so B might be a little trickier. Let's see. You know what? You can look at the very maximum point of 2 successive sort of waves there, like a 2 successive crests, if we're talking about science terminology there. But I don't really know what this is. I guess we could maybe figure that out. I don't really know what this is, so you could figure this out pretty easily, I suppose. Could we go from 0 to where the next point is? Well, it doesn't actually show up on the graph, so we might be in a little bit tight. I wonder, could we use this middle line that we identified here? And this is what I'm noticing. I'm noticing that in this midline here, we have this point, and then if I go over to 1 complete cycle, it ends up over here again. And this just happens to be on x values where we know what those values are. You see that? So try and be smart about it. You don't have to find this value, this value, this value, this value. You could. It's actually not too hard, I don't think. This is actually pi over 2, halfway. That's pi over 4. That's 3 pi over 4. Okay, so we could do that. But I'm noticing, one period length is just from one spot on the wave to the next spot that's identical on the wave, and that's here and here. So that looks like it's 1 pi this way and another pi, so that's a period length of 2 pi. So if we know the period length is 2 pi, we know that to calculate b, right, 2 pi equals 2 pi over b. Well, b is just 1. That is the given period length for a regular sine graph, and it appears to be the same length as a regular sine graph, okay? It might be obvious to you, might not be, but you want to calculate what this width is in total. Okay, so let's keep moving on here now. C. Okay, so this is where it gets tough. We could go to the right or to the left. We could phase shift this over. Obviously, we want to try and find where the start of this sine graph would be. So you know that a sine graph generally looks like this, right? So it appears that the start of what would be a sine graph is right on x equals 0. So we could say that, hey, you know what? We don't have to shift this over at all. So C is 0. We don't have to shift it left or right. It starts where a sine graph regularly starts. So the d value here is, again, the vertical displacement, okay? So obviously this graph is moved down 1 unit. From here's the start point and end point, right? So d is going to be -1 or a -1 value. Okay? So from the graph, are we able to do that? You feeling comfortable about confident with picking those parameters out? So y equals a sine b, so it's going to be 2. Sine of b is just 1. C is just 0, so that's just sine x, right? You don't have to put 1 bracket x minus 0 bracket. You don't have to write that. Just write it as sine x, okay? And then plus d or plus a -1 is the same as just -1. Okay, so it appears that here's the solution manual here. And y equals 2 sine x minus 1. I think that's what we had right here. So yeah, everything looks correct. Take a look at this if you want some further clarification. Anybody have any questions about that one? Okay. So drawing from an equation, drawing from a description, you have to know how to do that. Getting an equation from the graph is what we just did, and getting an equation from the description of the parameters, another thing. So if you know how to do those 4 things in this section, you'll be good to go. Okay? So there's a spattering of some homework from 5.2.